Good evening. This video was made by Aranya Arandra on 7th April 2018 for the assignment of Neural Networks and Fuzzy Logic subject to be submitted to Dr. Sanjay Singh, Faculty of ICT, MIT Mahe. The topic of my presentation is Artificial Neural Networks and Fuzzy Logic for System Modeling and Control. Let's begin. Neural networks are made of artificial neural nodes. These neurons are made of individual models of the biological neuron which are connected to form a network. The structure allows for information processing in a parallel distributed way, faster than conventional von Neumann computers. So von Neumann computers were based on the architecture made by von Neumann in 1945. So they say that the neural networks are very fast or faster than the single processor conventional von Neumann computer. Neural networks characterized by their learning and organizational capabilities. These make them adapt to variations in processing environment. And more specifically, neural networks can learn non-linear mapping between the input and output of a process. They have been theoretically shown to be able to approximate non-linear functions to arbitrary values. So for fuzzy logic, they say that fuzzy logic deals with uncertainties. Fuzzy logic, see, like as we've seen in neural networks is more about learning or improving, while fuzzy logic deals with the approximate values. See, fuzzy logic has emerged as a mathematical tool to deal with the uncertainties associated with human cognition process. Then can be considered as an extension of binary Boolean logic. Binary Boolean logic is what we've learned so far. Like, if an object is in a set, then it is 1, otherwise it's 0. Fuzzy logic deals with approximations, so there are no 0 and 1 fixed values, but rather a set, a value, the value can have value, the condition can have values from 0 as well as from the range of 0 to 1. Then the important application is FCL, fuzzy logic control. FCL emerged as a model of intelligent control capable of dealing with complex and difficult systems where conventional techniques don't work. They were made by Chang and Zadeh. Then shows approximation of non-linear functions to arbitrary accuracy. This is the similar as the neural networks last point. So neural networks, artificial neuron, information processing element which maps an n-dimensional input vector to a scalar output. So we can see here that the input vector is xt, which is n-dimensional vector, just based on the r to the power n dimensions. The output output is yt, which is a scalar value. So mathematically, neurons' learning ability can be put into a non-linear form, which is in the screen, non-linear form, which is r to the power n is pointing towards r, while xt is towards yt. It maps rn to r and xt to yt. So this non-linear form can be divided into 3 parts: the weighing function, aggregation function, and non-linear activation. The first two find the measure of similarity between the input vectors xt and the synaptic weight vector wt, which is given on the screen right now. So the synaptic weight vector represents the accumulated info in the neuron. So for fuzzy systems, generalization of the classical notion of the set, which is more of the Boolean logic, the binary Boolean logic, as I've mentioned before. So, and alternatively, in the fuzzy set theory, the subset C, called fuzzy subset, has a more realistic characterization in that its characteristic function is defined as mu c of t is equals to, it belongs to either in the range of 0 to 1 if t belongs to C set, subset C, and 0 if it does not belong. So what here is basically that the t can take a value, the mu c t can take a value from 0 to 1 rather than only 0 and 1, which was seen in the conventional Boolean logic, the crisp Boolean logic, you can say. In fuzzy logic, the value is approximate. See, we can see that for a value t belonging to a subset C with a degree of membership mu c t belonging to 0 and 1, mu c is called the membership function in the fuzzy set theory. So basics of the fuzzy logic control, which was FLC. So in fuzzy logic, there is a rule which is known as if-then rule, which basically said that if x is L of x, then y is L of y, where x and y are linguistic variables defined on the universes of discourse x and y, which basically means that the whole set of values that x and y can possibly take, while Lx and y are linguistic values of x and y respectively. Linguistic values are more defined, like very high, very low, medium, these things. And the meaning of the fuzzy if-then rule is given by a fuzzy relation R tilde defined by the function which we see on front, which is basically if we find x Cartesian product y, it gives us a value which is the minimum of the individual membership functions, membership values. So we can see that the conclusion is despite their computational capabilities and their ability to deal with complex problems, neural networks are currently unable to handle problems with perception and reasoning, which are very important for intelligent and autonomous systems. And on the other hand, fuzzy logic has provided a powerful tool for dealing with uncertainties associated with human cognition and reasoning. Due to this, fuzzy logic and neural networks have been integrated, yes, to form fuzzy neural networks. So these fuzzy neural networks are basically neural networks, low-level neural networks, which are aimed to improving or refining the fuzzy rules in the fuzzy system. With this, my presentation is over. All respective files will be attached in the mail. Thank you.